Good afternoon and good morning, everyone. It's Joe Fritsch with Crunchy Data. Thanks for attending this Lunch and Learn workshop on using free text search within PostgreSQL presented by Crunchy Data. Our speaker this morning is Mr. Steve Pousty. Steve is the Director of Developer Relations at Crunchy Data. Steve, please take it away.
Thanks, Joe. Hi, everybody. For today's webinar, we're going to cover free text search, which a bunch of people don't even know PostgreSQL has. So in continuing with our series last time, where we talked about JSON and how to work with JSON in Postgres, which a lot of developers and people don't know about, today we're going to talk about free text search. This is not, I want to make this clear, this is not n-grams or like searches. This is actually a full free text search engine. So for any of you who've used Elasticsearch or Solr or something like that, the engine underneath of that is called Lucene. And basically you have a Lucene-like engine inside of PostgreSQL, and we're going to show you how to use it today. Just to be absolutely clear, it does not use Lucene. It uses its own implementation of a free text search engine, but it's available for you to use. And so I'll get to it in a second about what's exciting about that. The link here on the slide is actually to the slide deck you're looking at right now. It's in Google Slides. So as long as your organization allows you to see slides outside of Google, you should be able to go to that link. I mean, outside of your own org. Sorry, not outside of Google. You should be able to go to that deck, and the deck has some links in it. This talk is not very slide heavy. It's mostly demo of free text search, but you might want it because it's got some follow-up links you might want to follow. If you cannot view Google Slides outside of your organization, just contact Joe, or reply to the email, and we'll send you the PDF of the slide deck as well. Okay, and again, the Steve 0 is where you can find me in most of the world electronically. It's my email at Crunchy, it's my Twitter handle, it's my GitHub handle. So most of the usual places you'll find me. All right, let's keep going. The agenda for today, it's pretty simple. I'm going to talk some about PostgreSQL in your org, explain some free text search capabilities in Postgres, show how to use it, show a nice demo of what it can help you do. All right. The two main points, this is general Postgres points I want to make. Actually, also before I get started, I would really appreciate it if you have any questions, if you put them in the chat, or you can interrupt with voice. I'm a very informal speaker, and I like questions. Questions are very helpful for me in that they allow me to see gauge how the audience is getting what I'm talking about. This is particularly helpful in webinars where I cannot see anybody's face. And so I can't gauge if there's confusion or what people are getting. So please, I encourage you to ask questions if you have them. Okay. So two main points I want to make. This is overall for Postgres. If you saw the other webinar, the JSON one, then you'll get this as well. But you've already seen these, but I'm going to make them again. I'll go through them a little bit quicker this time. The first one is I believe that PostgreSQL is the 80% in the 80-20 rule. The 80-20 rule is like basically 80% of the functionality you need in an application you can get with 20%. You can get there very quickly, or you can get that with very simple solutions. It's the last 20% that's hard, and I believe for most applications that people write, PostgreSQL meets 80% of application requirements. Most applications, once they learn what PostgreSQL can do, can use just PostgreSQL for their application as their single data store. I think most people don't understand all the capabilities inside of it, right? And so Mark Twain had something to say about this. It's always start with PostgreSQL, then if and when you need more, look to other solutions. Right, most of you are already probably using Postgres. There might be reasons you're looking at other data stores. So if you might be saying, oh, I need to use JSON, so therefore I'm going to look at something like Mongo. Actually, that's not necessarily the case, as we showed in our last webinar. In this case, you might say, oh, I need free text search, so I'm going to have to put in Elasticsearch, or I'm going to have to put in Solr. And there's a lot of things that Elasticsearch and Solr that for free text search that Postgres doesn't do. But if you're just looking for a particular free text search capabilities, that actually is available, and you don't actually have to add the complication of adding a whole new set of server-side functionality and another set of servers to install and manage and the resources that they require. You can use technology you already know really well. I think for most people, before you start saying, oh, I need this other technology because I'm using feature X, Y, or Z, I would recommend, if you're already using Postgres, to look in the Postgres documentation, try it out, see if it works, then go back to the documentation if it doesn't work as expected, and then read it again. And then if and when you get to that point where it's not scaling properly or it doesn't have what you actually need, explore other options. And then the other one is, and this is more general, even just for any relational database or any data store, do as much as you can on the server, right? And so the idea with this is, I think we as developers tend to learn a little bit of SQL, enough to get us by, and then we tend to do a lot of work in our code, where if we learned a little more SQL, we could actually get a lot done on the database engine itself, and that would greatly improve the speed and functionality of our application. Um, there's some quotes here from Sun Tzu on this one. Keep operations as close to the data as possible and minimize the data over the network. This is how you defeat your enemies, right? So shipping, one of the slowest parts of our application is actually shipping data over the wire and then processing it on our side. PostgreSQL, quite advanced and quite mature now, and that query planner that they've built into Postgres has built in a ton of optimizations that you and your team probably would either miss or don't even know how to do. And so you can leverage all that expertise that's gone into the query planner to make the operations go faster. Plus, you'll also be doing, if you do the operations on the database, then you're doing the operations exactly where the data is, as opposed to having to slurp it over to the network to your side, build a whole bunch of objects, and then process it. You could actually do it, return a very small result set that's focused, or at least even in the order that you want it to be. And if you look at some of the functions that are available in Postgres, you can actually do quite a lot of functioning. You can actually create your JSON response actually in Postgres, or you could actually create arrays in Postgres itself rather than having to slip them over as arrays into your data store and then creating them into arrays on your data, on your application. All right, and so Rabbi Akiva, with his wisdom, said, to be a good person, study SQL deeply, the rest is commentary. This is the last little bit of advice, which is, I think, as application developers, I think we are better served by spending some time learning some more SQL. I think for most of us, the investment in SQL will pay off handsomely in terms of quality and performance in our code. And with that aside, now the exercises I'm going to do today, they're available at home, or wherever you are, and they're available 24/7 for free. Today we're going to go into, it's all available at learn.crunchydata.com. Basically what we're going to do, actually I think that link, learn.crunchydata.com is wrong. Yeah, the rest of the part is wrong, sorry. Learn.crunchydata.com is correct, right? That is here. We did some reorg on the site. I'll update the slides right after the webinar to make it. What you want to do is go to learn.crunchydata.com, go to PostgreSQL for application developers. You can, just a second. We have a whole bunch of free learning modules here. We have some on PostgreSQL administration. We have a whole section on PostGIS. And the ones that are filled out now is also PostgreSQL for application developers. We will be adding advanced concepts and PostgreSQL for Kubernetes and OpenShift soon. So today we're going to go into PostgreSQL for application developers. We're going to go into the beyond PostgreSQL basics, right? There's a basic section, but we're going to go into the beyond basics, and we're going to do full text search. So you can go to the site, learn.crunchydata.com, anytime you want, 24/7, and it'll start a scenario just like this. So I'm just going to walk us through the scenario because I think this is actually quite useful, and then it's got the examples built in. It's going to basically start up an environment for us that already has Postgres running, and it's going to have data loaded from historical storm event data in the United States, right? And we're going to have the database is going to have a username Groot, the password is password, and the database is named workshop. Right, and we're just going to cover briefly some of the stuff that happens in full text search today, not in depth, everything you need to know about full text search. This is just more of like a whetting your appetite so you play with it more. Before we get into full text search, I need to give some basic ideas about what happens in full text search, right? So full text search is not like a like search, or I like, which is case insensitive. This is actually a full text search engine, like I said earlier. And so when you do, this is the same concepts that apply in Lucene, which is the engine underneath of Solr and Elasticsearch. When you do this kind of searching, you actually are creating, you pre-compute your search indices that you're going to search against. And the first step in doing this is you have to make a document, right? And most often, I think for most of our use cases, a document in this case will just be a column, right? But it could be, you can concatenate 3 different columns together if you wanted to search against something, right? So there could be something like, if you're searching against people and you want to make a first full text search, you could have something like last name, mother's maiden name. You could have a whole bunch of different names concatenated together if you wanted to have a really broad ability to search. Or if you were searching on some geographical entities, you might have like the official name, some nicknames, a whole bunch of other things that you put together into a single quote unquote document, right? And that becomes the object that you're searching on. Once you have that document, you pass it into the full text analyzer. And the first part of that is called a tokenizer. And the full text, the tokenizer, what it does is it basically just goes through and makes tokens out of all the words, if you can think about it, right? So for most tokenizers, what they say is any white space marks the beginning and end of a token. Right. So basically, we're taking this stream of text and breaking it into tokens. Like if you're a Python developer, basically, or a Java developer, we're splitting the text on a white space, right? And we're calling those tokens. But with the full text tokenizer, you can actually have special types of tokens. So you can say things like, if it starts with HTTP : / or HTTPS : / that's a URL. So treat that as a URL token. Or you could say, if it's all digits, this is just a number, and I want to treat that as a number, right? And so you can create special tokens. You can actually make your own, you can actually, since it's all open source, you can take the standard tokenizer and you can adapt it. This might be, for example, if you had if you were a pharmaceutical company or a chemical company, you could have a tokenizer that learned that if it was like C6O2, like that's considered a chemical formula, and I want to call that or a molecule. You could say that's a molecule. Tokenize that as a molecule, right, and treat it differently. Okay, so once we've taken our document and turned it into a bunch of tokens, the next thing we need to do is then pass a dictionary over it, right? And that in Postgres, they call this doing lexeme analysis, LEXEME analysis. And so what lexemes are one of the things it does is it strips out stop words, right? So in English, that would be like is, the, I, you. Those aren't things we usually search on, words that we search on. And so we don't want to actually take space in the index, and we don't want to make the index larger, bloat it, have to analyze it. We just yank those words out and don't put them in our index. The other things the lexemes will do is it'll find roots for words, right? So it'll know that car is the root for cars. So if I search on car, it might give me car and cars. Or if I search on cars, it can return car as well. It'll do all that rooting and stemming and put that in there so it understands what's going on, right? And so after you've done that, what you get out is a vector, which has the word and then position of those words within that vector and occurrences of it, right? How often it occurs and things like that. So now you've got that vector, you can then store that either into a column or in an index, right? And there's some benefits to each. If you store it in a column, then it makes the search syntax look a little nicer. But every time you update any value or you insert new values, you'll have to have a trigger that actually updates the column that contains the vectors, right? If you just store it in an index, the search syntax looks a little weirder, and that's what we're going to use an index today. So you'll see what the search syntax looks like, and I'll explain that when we get there. But you don't have to write the trigger because indexes know on, update, delete, all that stuff, update yourself. So the index auto updates whenever you add new records in, right? And then finally, now you've got your data stored. Now, when you do a search against that vector, you need to use a search analyzer that knows how to do the same kinds of things, understands the syntax. So there's a special search function that we'll use and you have to use the same dictionary as well, right? So you have to pass the same dictionary in so that it analyzes it properly, right? And that's a basic introduction to full text search. The first thing I'm going to do is show you our data. So let's go ahead and log into our database. Can everybody see my console on the right-hand side well? Is that large enough?
Yes, looks good, Steve.
Okay, cool. So we're in our database now, and I'm going to show you our table, which is SE details, which is storm event details. Again, these are historical storms. This is public domain data. I like using that because then people can use it at home if they want. We're going to describe the table. It's got a whole bunch of information, but the one we're going to do full text search on is event narrative, right? So whoever entered the storm event data, they put in a narrative around the event, and that's got a bunch of text in it. And so that's the field we're going to treat as our document today. And you can see we only have one index as of now, which is just the primary key index, right? I wanted to show you how, since the index is important for full text search, I want to walk you through how to create the index and see what it's about. So there's our table. Let's build the index. So we're going to do this statement over here on the left. Create index, SE details, full text, our name, right? On the SE details field using GIN. So GIN is one of the generalized indices types. There's GIN, GIN, and GIST, GIST. One of the differences between GIN and GIST is GIN is lossless and GIST is lossy in its indexing. GIN, it's an inverted, oh, what's the word? Sorry, I'm a little jet lagged right now. So it's an inverted index. And what we're going to do is we're going to create a GIN, and then this 2TS vector, this is going to say create full text vectors using the English dictionary on the event narrative field, right? And then index it using a GIN index, right? So we calculate the index and then we index it. Calculate the vector and then we index it. So let's go ahead and do it. And it takes a little bit because it goes through, and that analyzed on, let's see, select. That was analyzing. About 55,000 records, right? So that's how long it took on a fairly low-powered machine to do 55,000 records. So it's done. We did the tokenizing, all that stuff, and now if you want to see what other dictionaries we could have used, right, there's all the dictionaries that come out of the box. We used English, but there's a whole bunch of others. What I would say is if you're going to build your own dictionary, I would recommend starting in general. These are all available in the Postgres repository, Git repository. I would recommend starting with one of these and modifying that to create your own dictionary. Same thing with the tokenizer. Start with one of the standards and modify it rather than trying to create one from scratch. You have to be an administrator on the database to install a dictionary or a tokenizer. Okay, that's not a standard user's capability. So I already talked a little bit about here we talk about why storing in an index versus storing it in a column. I already talked about that, so let's move on. Let's use the index. So what we're going to do with this one now is we're going to we're going to return the begin date time. So what's the event narrative, the actual narrative from SE details. So that's our table so here, this is the part you're like, wait, Steve, didn't I already do a TS vector on event narrative? Yes, you did. But we have to put it here, this 2TS vector English event narrative. The reason we use that syntax again, like we did in the index, this is the clue to the query planner to use the index, right? If we had made a column, we could just pass in the column name here. We wouldn't have to use the index, the same call to create a vector. It's not actually going to go through and recalculate all the vectors again. It's just in the query, this is how you tell the query planner, oh, go use the index if there's an index available. If we didn't have the index available, it would go through and have to do that for every single one, which would be really slow, but we already pre-calculated the index. Then we say add and that's to say, oh, we're about to do a full text query. And then we say to TS query vlog. And the reason I'm leaving the E off the end is to show you that the dictionary knows that vlog is the root for village or villages, right? And so when we do this query, let me clear the screen here. Right. And so it's big output. We're going to have to scroll through like this but you'll see some of the results in a sec. Okay, so here we go. You can see we've got, where is it? Here, so here's villages, right? And then here's village. And so that's basically saying that works this way because those are both valid stems for, or suffixes for villag, right? Notice I didn't have to put any special like operator in there to say, like I would in a like search where I would put a % in. It just knows, oh, these are all the valid forms of things after that villag could fill in, right? So if I switch that though now to something like, let me just quit this. So I don't think anybody needs to see any more of those results, right? So if I quit that and go back up top again to clear the screen. If I do this now, this is how you do a, if you wanted to do like the % sign in a like query or like saying, wildcard at the end, it's : :*, right? And that we're going to do that with the Villa here. And this Villa, well, let me do it first. Actually, I'm going to quit and show you the same query without the star in it, right? So if I get rid of this star, you'll notice we won't get any villages, right? There's not any villages in this one because villa is a valid word in and of itself. It's not necessarily the root of villages. I mean, it kind of is, but it's not, lexically speaking, it's not the same thing. And so we only get villas on this one, right? There's not going to be any villages. But if I wanted to say I want villas and villages, I can use that : (*, right? I can use that : (* here to get all of them. So that's how you do like a wildcard search, right? And so if we do this now, we'll probably only see villages at the beginning. And for most of this, I'd have to search quite a bit to get to villas because villages is more, much more common. And I can't scan through this fast enough to find them, right? So most of what I'm finding is villages here. There is a way with full text search that I'm not showing here where you can get back it to highlight the phrases that it actually found, right? So where is the actual occurrence of the word? So you could use and also you can change boosting and ranking of words, how things are ranked inside of a document, all that kind of stuff. So you have the ability, and even of types, right? So you have the ability with the full text engine to do a Google-like search, give a Google-like search to your end users. If you were to do something like that, you would basically have to you could give the end user their Google's, allow them to put stuff with Google-like syntax, and then you on your backend and your application would just translate that to the full text search syntax using the different operators and things like that within full text search. Okay. Any questions so far? Let me go back and see the chat window. See if anybody has any questions. I'm not seeing any, so I guess I'll keep going. All right, so the next thing we can do now is we can also, you can do proximity searches. So you can say, I want to find this word within this many words of another word. And the syntax for that, everything else stays the same here, right? Well, the only thing we've changed is in the TS query, we're saying grapefruit, and we do this operator to say word. What this is actually showing is look for word boundaries, right? So how many word boundaries in between the two words? It's not how many words are in between the two words, it's word boundaries. So in this case, a 1 means there's a one word boundary between the two words, which means that they'd actually be right next to each other, right? So if I do this, we're not going to get any results. Why? Because we never say grapefruit hail, right? We always use another word in between, which is something like grapefruit sized hail, right? And I also love and am horrified by this topic at the same time, because if you think of grapefruit sized hail, that's like they have a separate category for softball. So grapefruit is larger than a softball. So that's basically almost like a cannonball, a small cannonball falling from the sky, which is crazy to me. I want nothing. I mean, that's one of those things that's interesting to see when you're inside a concrete bunker, and otherwise I want no part of it. Anyway, that little aside. So what we really wanted is something like this with 2 word boundaries, right? So if we do this, we get 2 grapefruit-sized hails happening, right? We can also do we can also do something. Order matters, right? So when you do these proximity searches, order matters of what orders you put them in. So if I change this around and I say I want hail with 2 word boundaries of grapefruit, I'm going to get no results because we never say hail-sized grapefruit, right? So that's one of the proximity searchings you can do. You can also use standard SQL operators like or not inside the 2TS query. You're probably going to want to start using this, and you're probably going to want to start using parentheses to group search things together. So here's probably the last query we're going to show for today. And the example with it is we're going to look through either grapefruit or golf, anything with golf at the beginning. I'm going to stem it like we did before. Hail, and 2 word boundaries to hail. So if I do this one, now I start getting things like, see, I can get golf ball. All right, but if we keep going, I think, if I remember correctly, there's sometimes people write golf ball, right? So we get either one of those because we did that stemming, right? So it's a really powerful way for us to do full text search on a field and be much more general than just being constrained by something like a regex or a like query. So that's the general presentation and specific demo, and you can go play with it at any time. The one caveat I do have is the documentation on full text search is it's written by non-native English speakers, and it's written as if you know a lot about full text search. So be ready to do a little bit of extra work when you deal with this documentation. And one of the things you're probably, and I give a link to it in the slides here. Let me show you actually back in the slides. Right. Free text search. All right, covered all this one. There's the normal doc, right? Then so this is the normal doc on free text search, right? There's a whole section on it. They talk about using synonyms and thesauruses and all that stuff that you can do. Thesauruses are really powerful as well, right? Because you don't want, one example might be if you were building a geocoder, right? A geocoder is the ability to take an address and put that as a point on the globe. If you're building a geocoder, you would want the word street to also have a synonym of ST, STR, right? Because those are other abbreviations people use for the word street, and you don't want people to have to type all those different ones out or get it exactly right, right? They could put in ST and get street or get STR, right? And so synonyms are really helpful for that, right? One of the sections you're really going to want to play with is this testing and debugging text search, especially because of a little bit of roughness of the documentation. With the debugging, you can actually go through and debug your query against a phrase that you know it's supposed to work on, and it'll show you how it's actually analyzing the text and what it's doing behind the scenes. Okay. One other thing, there is a very large slide deck by the original authors of this of full text search, and it has a lot of helpful information here, right? It's a 84-page slide deck that he gave as a presentation at PGConf EU 2 years ago, or actually a little over a year ago, right? So I highly recommend going through this to pull out some nuggets as well. It's a good supplement to the official documentation. Let me just show you, I want to show you another demo of the power of full text search. And actually, this is combining full text search with PostGIS, right? So as I said in the JSON webinar, and again with free text search, one of the great parts about this is you can mix and match all this technology on one server, right? It's not like you can't do JSON with free text search. You could actually, if you wanted to, you could free text search and index your JSON documents if you wanted to be able to do like a free text search on them. There's nothing to stop you from doing that. In this case, what we're going to do is Paul Ramsey, one of my coworkers and the lead on PostGIS, took the geo names. So the US government puts out a list of all the named places, the Geographic Naming and Information Service, I think, GNIS, puts out a list of all the named places in the United States, all 50 states. And they have a lat long for each one of those states. So what Paul's like, oh, this is really fun. I can use free text search along with PostGIS, and I'm going to create a application where when I type in an address or a name, part of a name, it's going to actually show me a heat map of all the places where that name shows up, right? So for example, let me reload this app. Let me reload the page. Get rid of the word. We'll start with a very common one where I am in California is Santa, right? And I say, okay, yeah, let's search on Santa. And there you can see all the places where Santa is part of the name of a place, right? And so what's exciting about this is also you can see how the obvious Spanish influence in where most of those names show up, right? And this is using the full, so he's using the full text search to search on the names of the places, right? So I can just put in arbitrary names and it figures out how to do it really quickly. And but you can also use the geography coordinates to give you back this heat map. The other thing we can do is we can change Santa to Saint, right? And then you can see there's a nice in Louisiana, right? And some of the more Catholic places in the United States that are not Spanish speaking, you can see a bunch more of these saints show up, right? The other interesting point is the Salt Lake City, right, which I thought was pretty interesting. That is probably not a Catholic influence. That's probably more of a Mormon influence, but they still use saint a lot in their names of their places. I thought that was pretty interesting. Another one, this is a fun one for me, growing up in New York. We learn about the Dutch and their influence on New York, and kill in Dutch is basically a name for a creek. So rather than saying, Vander's Creek, you would say Vanderkill, right? And so if I do kill, you can see that nice influence of the Dutch going up and down the Hudson River, right? And naming places as I saw them. So this again is using free text search. He's using the free text search index. I've connected to it here. And so it's the geonames, and if I do D, right, there's the geonames table, and I can go through and I can go D geonames, right? And you can see we've created a TS vector take column. So in this example, Paul made a column that was 2 TS vector type. And so I can actually use that directly in my queries. I can use TS directly in my queries without having to do the @2 TS vector on that one. And there's the index on it using the gen index on that column though, again, right? So that's how he did it, and that's what we're searching against. And then he actually did some stuff with the geoname stats table. That's where he gets to do the geoname stats, right? And this is where he's actually giving you the count, the number of documents that actually have that word and the word in it. Right? So he went through and analyzed it. He's just doing a normal B-tree index on that one. And using those two together with some Python code is what we do to create all of our stuff. So if we look at our, I'm assuming it's okay. I have a little time left. I can show the Python code for our queries, right? Here's where the query is happening. So what he's doing is with names, he's in where to TS. See, he gets to just say where TS, just use the column name. And he says plain into TS query, English. And basically what happens is whatever we type in gets put in to this part right here. And then he's doing a JSON aggregation over them. And he's limiting it to 1,000. This is what's giving our type of, this is what's giving us our type ahead search. So that when we do this stuff like this, what's another one that we want to look up? Oh, if we want to find Nordic people, let's do something like Swede, right? See how we're getting this is all being, that's that function that's being used for getting the suggestions, right? So we do Sweden, not so exciting. Let's do Swedberg. One little place. I think it's actually returning this in numbers order. But here you can see some of the Swede influence as they migrate across the country, mostly in the northern parts, not so much in the southern parts. And so that's that Postgres the Python, sorry, that I showed. That was the here. Oh, actually, this is the autocomplete. What he's doing again, right? And here he's using the stats table. So he took all the lexemes that have been analyzed, put them in that stats table. And so what we do now is as we do that typing, he's ordering by the number of documents so that he can give ones that have more occurrences at the top of that autocomplete search. Then once we do the actual word in, this is how he gets back the results to do the heat map. Okay. So that code is all open source as well. And the rest of the part is just executing SQL and handling HTTP requests. So that's one example. The other example, but I'm not going to show it today, is this is if you have, we showed this, actually you can find him doing this with our PostGIS Day video, which Joe can send around the link to the PostGIS Day video where he does this. He used the full text index to build a rooftop geocoder for Santa Clara County. Santa Clara County publishes their parcel indexes. They actually publish the street address for their parcels. And so what it's really very easy to do is to take, they break it apart, right? Like they have house number, they have street name, they have zip code, they have those all in separate fields. What Paul does when he makes that index is he concatenates all of those into a single address field. He built a thesaurus for street name, like I was talking about before, like street, ST, STR, street, all of that. And then he basically full text indexes those the concatenated things, but ties it to the Latin long for that parcel, right? The point inside the parcel. And so there, it's very easy to do a look ahead typing full text index, and then actually give back the address, the top, the point right on top of the parcel, rather than some interpolated range on the street like you would get with a normal geocoder. Right? And that's just because a lot of geographies in the United States, a lot of counties in the United States actually publish their parcel data now in shapefiles, and they usually have an address in there, so it's quite easy to build a free-to-form full-text geocoder using the free text search field, which would not be possible without the free text functionality. So the code for that is open as well. Again, send an email to Joe, and we can hook you up with either one of those codes. And with that, I am going to give my final slides. All right, so there's the debugging. Big take homes. I hope you thought this was fun. I think it actually is fun playing with full text search. It is powerful. I think both the example I showed and even just the example of looking for hail, showing word boundaries and things like that is stuff that would be very complicated to do otherwise, I think, and not as flexible. We just scratched the surface, not the service of what you can do. Really, this was just to get you excited. And I showed mixing and matching this with other things that you work with. So PostGIS and Postgres and free text search gives you powerful combinations. Same thing with JSON. Anywhere you're analyzing text and wanting to return other information about that thing. And that's the end. And there's the link again to the slides. And that's how you can contact me. And I'll be happy to take questions now, either by voice or by chat, depending on whether you want to talk or just type. Oh, I thought of, okay, I just got one question on the side. This is not an extension. This is actually included directly with Postgres. So there's nothing, there is nothing extra to install. It's just available. You may have to, it's an extension that's included in core. You may have to turn it on, but there's nothing in particular that requires extra installation for it. Yeah, so the next question was, how about searches where word order is ambiguous? Yeah, you just wouldn't use that, the boundary operator like I was using. You could just put the words in without the boundary operator. So let's go back. That's a good question. Let's go back to our session. Right here. So what you would do, so this one that didn't work before, right? Oops. So where we were, this is the one where hail with 2-word boundaries for grapefruit, which is a nonsense phrase. If I get rid of this, now I'm trying, this is now I get in trouble. Hold on one sec. Oh, that's right. I need to use you want hail and grapefruit, right? So the and operator was, that's the or operator. So I can do hail or grapefruit. I think the and operator was this, there. So there you get that just is just grapefruit, the word grapefruit and hail together. See, the interesting part about this one is great ball. We get great ball, grapefruit to softball, which didn't show up with the word operator one because we said we only wanted one word in between them. This one actually has it has 3 word boundaries, not 2 word boundaries, and so it wouldn't show up with the 2 one. This is arbitrary, arbitrary, if that makes sense. Does that answer your question? I hope so. Let me see. Go back to the chat. Okay. Any other questions? Oh, and one other thing I didn't point out that I should point out is you can have multiple free text searches on the same table. So why might you want to do something like this? It's for something like there's the narrative, right? And then there's another, like there's something about the there's the event narrative. Oh, there was the event narrative, and then there was also, like, let's say the author. Who's the author of this one? Or there was, like, we're talking about storm events, so you can maybe have free text search on destruction, right? There's a destruction field or damage field, and you want to search specifically in the damage field. You don't want to necessarily put those into one document because you want users to be able to say, oh, well, from this part, from the narrative, I want to know if there's people involved, and from the destruction field, I want to know the magnitude. I want to search this part of the destruction, right? Does that make sense? So that might be one way to do it. Does the Python code show heat map use, the PS Python plugin? I don't think so. Let me check. I didn't actually dig in on that. We can look together though. Let's see. Did you see it somewhere in there? Person who typed stuff in? Okay, generate SQL, turn CGI query into SQL. Looks like I don't see it. He's writing let's see what's the results. Read the term. Yeah. Okay. No, I don't think so. I think he's just executing the SQL and then returning the results as a vector and then using probably, I think he's probably, if I actually, so hold on one second. I'll open file. Let's see if we're, yes. Let's look up in the, if I'm guessing, if I look in the geonames lookup, this is the actual HTML page we were looking at. I'm expecting that somewhere in here, he's using Leaflet, and I'm assuming he's using he's using Leaflet to do it. Right, he's using the heat map component in Leaflet. Hope that was helpful. Yep, no problem. But he could do, depending on how you do it, there's all sorts of different ways to make the heat map. So he could have done something server side, but in this case, he chose to use Leaflet, probably quicker and easier. Any other questions? Yum, update. Never mind. I think Jane's typed in the wrong window. Jane's, now is not the time to update your machine while you're watching this enticing and all-encompassing webinar. Sorry. All right. Looks like that's it. Thanks, everyone, and I hope you enjoyed today's webinar.
Thanks, everyone, for attending this Lunch and Learn session on full text search presented by Steve Pousty and Crunchy Data. If you have any questions or need more info, feel free to email joe.fritch@crunchdata.com, and we'll get you the info that you asked for. Thanks again. Enjoy your day.